We're going to take a look at section 2.1, which is sets and subsets. First of all, this section is pretty heavy on the vocabulary, but thankfully the vocabulary is not very difficult, so I think you're actually going to like this section. Set notation. So I want to take a look at a definition of sets based on something that you'll be familiar with. Let's talk about the Southern Baptist Convention. So the Southern Baptist Convention is made up of autonomous churches. So for example, this is Sweetwater Baptist Church, small church in rural Alabama. And this is First Baptist New Orleans, and this is just a cute little country church I found a picture of on the internet. And so according to some research, there are 51,379 churches in the Southern Baptist Convention based on current data. Okay, so now we can write this in set notation. So let's talk about how we do that. In mathematical terms, if we wanted to write this in set notation, this is how it would look. So let's explain all of the different parts of set notation. First of all, we have a capital letter S. So all sets are written with a capital letter. So that's important to note. Then we have this equal sign. The equal sign means how are you going to define your set? So in this particular case, we're defining our set with the Southern Baptist churches. Then you have these braces, and the braces basically contain your set. So you're between those braces, you're going to sandwich your set. So those are the different parts of your set notation. Okay, so that's the big parts of your set notation. Now let's talk about some different types of set notation. The first one is called the description method. So how you see it written here, S is equal to the bracket Southern Baptist churches. That is the set of all Southern Baptist churches. It's just kind of, we're describing our set. So that's why it's called the description method. There is also called the roster method. The roster method is what you would think of. So for example, the roster method would be where you would list all of the churches. Now, thankfully for you, we are not going to list all 51,000 some odd churches, but you would list them. So Sweetwater Baptist Church, First Baptist New Orleans, Carmi, Midway, and so on, 51,000 churches. So you would list them. One thing is to say that each church is an element of the set S. Each church and each element you would separate with a comma. So that's another important terminology here. So let's look at an example here. So this is one of your homework examples. Specify the set by roster. So the set A is equal to the distinct letters in the word church. Okay, distinct is the key here. Distinct means that they are different. The letters are different. You can tell them apart. So let's look at each individual letter. So the first letter is C. So C has to be in my set. So I'm going to go ahead and come down and I'm going to start my set, the set A. A is equal, and I've got my little bracket there, and I have a C. All right, now H is different than C, so it is distinct, and so it also has to be in my set. U is different than C and H, so it has to be in there. R is different than those, so it has to be in there. Then I get to C. Well, C, I can't tell that C apart from the first C. So it is not distinct. So I do not put it again. Okay, so then H, we already have an H, so it is not distinct. So these are all of the distinct letters. So that is the distinct, those are the distinct letters, C, H, U, and R. Now, most of the time, the difficult part to this example is actually how you type it in WebAssign. So in WebAssign, you're just going to have a box. And in that box, all that they want is for you to put your bracket. Your bracket is actually next to the letter P. You just have to hit Shift, and on your keyboard it's next to the letter P with the Shift key. And then do a C, and then comma, H, comma, U, comma, R, and then the other closed bracket. So that's exactly how you'll type that in there. So it's very, again, WebAssign is particular, so make sure that that's how you type that in there. You will not type in like A is equal to. That's all you'll type in there, just like you see it. Okay. All right, so let's type in now. This says specify the set by description. So this is a little more tricky here. You've got the numbers 5, 10, 15, and so on up through 95. So I'm going to give you a couple of choices here. You have the multiples of 5 between 5 and 95, and you have the multiples of 5 between 0 and 100. So it's tempting to think that these are saying the same thing, but I want you to kind of think about these two things, because in math we are very specific in what we're saying here. So when you are saying that you are between 5 and 95 and between 0 and 100, you're actually saying two totally separate things. And if you don't believe that, ask the police officer whenever you get pulled over for speeding. So whenever you say you're between 5 and 95, there's a big difference between 5 and 95 and 0 and 100. And so between the two things does not mean on the two things. So in other words, like if you are traveling on a road and they tell you to stay between the lines, that means your car needs to be between the lines, not on the lines. Okay? Stay between the ditches, not on the ditches or in the ditches. So, so in this case, if you can think about these numbers and you think about these outer numbers of set A, we have 5 and 95. And I want you to think about the road lines of that. 5 and 95 are my outer boundaries. Okay, so I need to make sure the multiples of 5, I'm going to have to choose this second group because 0 and 100, those are the multiples of 5 between 0 and 100, not between 5 and 95. Okay, because I have to have my borders on the outside. All right, so hopefully that makes sense, that you've got to have some wiggle room on the outside. So all of these, because it was by description, I've got to have a little bit of border room on the outside. So I've got to have a 0 over here and 100 over here, and that gives me room for everything in between. All right. So I've got 0 down here and 100 over here. All right, let's take a look at the next one. All right, so now we're going to take a look at elements of our set. So we have the set S of Southern Baptist churches. We have different churches that are listed in this set. Sweetwater Baptist Church we have this funny looking E, and that E right there means that Sweetwater Baptist Church is an element of S. Okay, so then we also can say that Hope Methodist Church is not an element of S. So the E with a slash through it means that it is not an element of S. So that's how we would write that it is not an element. And you'll have some homework assignments that will use that notation as well. Okay. Now we're going to talk about well-defined versus not well-defined. All right, the set A is equal to 50 states of the USA. Now, if it is well-defined, that means that everybody should be able to tell me what that set looks like. And so, in other words, I should be able to go to Google and I should be able to put this in here, and you should be able to give me the answer and know exactly what it is. Everybody should be able to go to Google, type in what are the 50 states of USA, and you should be able to get an answer. So that is well defined. All right, now the set F is equal to the foods that I like. Now, if you were to go to Google and you were to type in, what are the foods that Lisa Baker likes? You are not going to get an answer. Okay, so that is not a well-defined set because Google does not know the foods that I like, or at least I hope Google doesn't know the foods that I like. So that is something that is subjective. I mean, you know, not everybody knows that. And so that is not well defined. So that is well defined versus not well defined. You got a couple of easy questions about that. All right, now we have set builder notation. Set builder notation. The set D is made up of men. Okay, the set of all men. Now this straight line right here means such that. The set of all men such that the men are deacons at Sweetwater Baptist Church. Okay, so now that is more of a descriptive set. And so this is called set builder notation. The set D of all men such that the men are deacons at Sweetwater Baptist Church. Now this is going to be a mathematical set builder notation. The set of all X's such that those X's or numbers those numbers are less than or equal to 10. That's what this means. The numbers are less than or equal to 10. So let's think about a number that is in this category. So for example, a number that's in this category would be 4. Okay, so another number that is in this category would be 2.7. Another number that's in this category would be -3. So those are all numbers that are in this particular set. All right. So this is called set builder notation. Again, this is all very much vocabulary driven. All right, so now we're going to take a look at some famous mathematical sets. All of these sets kind of build on each other. The first is your natural numbers. These are your counting numbers. These are the numbers that you've known since you were, you started out at 2 years old and you started counting numbers. So 1, 2, 3, 4, 5. Now, when you added 0 to that, you started learning the whole numbers, okay? So when you add 0 to the natural numbers, you get the whole numbers. Then you started learning that there was a whole nother part. There were the negative numbers. So the negative numbers, when you added the negative numbers to those whole numbers, you got the integers. So the natural numbers are the set N, the whole numbers are the set W, the integers, we call that the set Z. Then whenever you take the integers and you start adding in all of these weird little numbers in between, like fractions and decimals, all of those numbers in between, that is called the rational numbers. So that is called the set Q. All right, these are famous mathematical sets. All right. Now we're going to talk about set notation with the empty set. There are several different ways that we talk about sets that don't have anything in them. And this drives people crazy sometimes that we talk about this, but it's necessary to talk about. All right, the set A is the empty set, or we often call it the null set. Okay, so sometimes you'll call this the null set or empty set. You'll oftentimes see it written with an empty set of brackets. You will also see it written with this 0 with a slash through it. Okay, that's another way you'll see it written. Okay, so let's talk about these 3 different ways that you will see this written, because these 3 different ways are 3 different things right here. These mean 3 different things. All right, the first one, this is the empty set. This is a set with nothing in it, okay? The second one that you see in the middle here, this right here is the number 0. That is an actual number. This is a set. This is the number 0. The last one right here, this is a set with one member, and that member is the empty set. Okay, this set right here is not empty. This is an empty set. This set actually has a member. The member is the empty set, which I know is absolutely wild, but it actually has a member, and the member is the empty set. So I think you actually have a homework question that asks you the difference between these 3 things. So that is the difference between these 3 things. So let's take a look at cardinality. So when you're asked to take and find the cardinality of a set, if we take a look at this particular set, it has 4 elements of this set. And so the cardinality of a set is just the number of elements of that set. So you'll see it written as A with these sticks next to it, and so they want to know how many elements are in the set. So the cardinality of this set is just 4 because there's 4 elements of this set. Now if you were asked to look at set B, then the cardinality of B is going to be 5 because there are 5 elements of this set. So cardinality turns out to be pretty easy. We're getting near to the end, just a couple more slides. We have equal and equivalent. A equals B if they contain the same elements. And then you have equivalent if they contain the same number of elements. So this is where cardinality kind of works back into place. Let's look at an example. So I've given you 5 different sets here, which all look similar but yet different. So we have A, which has the number 21 in it, B, which has 20 plus 1, okay, that's a math operation in there. We have C, which has the number 20 and the number 1. We have D, which has X and Y. And then we have E, which has this word 21 in it. Okay, so let's take a look at how this is all going to play out. So let's first talk about which sets are equal and which sets are equivalent. So first, let's talk about which ones are equal. All right, so if they contain the same elements, all right, so A has the element 21 in it. Okay, that's the number 21. B, if you perform this operation, that has the number 21 in it. So A and B both have the number 21 in it. Now C does not have the number 21 in it. It has the number 20 and it has the number 1, but it does not have the number 21 in it. D does not have 21 in it. Now E has the number 21 in it. It's just written in word form, but yet it's the same 21. So actually A, B, and E are the same. They are equal because elements, they are the same elements, okay? So in other words, if you go back to thinking about churches, if you were to have a picture of Sweetwater Baptist Church, or you were to write Sweetwater Baptist Church, they would mean the same thing, right? Because they're both, it's just 2 different ways of representing the same thing. Or if you were to have a picture of Lisa Baker, or you were to write Lisa Baker, we would be the same thing. So that's what I'm saying, it's the same element. So actually A, B, and E are all equal. And notice how we would write that. We wrote them A equals B equals E because that's the notation here. So those are all equal. Now, equivalent means that they have the same number of elements. So we actually are going to look at the cardinality of each of these sets. So let's do that. The cardinality of set A is 1 because it has just that one element. B only has one element because I performed the math operation and I got that it has one element. C has 2 elements, D has 2 elements, and E has 1 element. So when you look at cardinality, A, B, and E are going to be equivalent. And notice we use this little double arrow to show equivalent. And then C and D are going to be equivalent because they both have 2 elements. So that's the difference between equals and equivalent. Okay. All right, one last example and we'll be done. In this last example, we're going to look at subsets. And so we're going to look at this one set that has A and it has 3 elements, 1, 2, and 3. And in your homework, you're going to be asked, how many subsets of A are there? So we're going to actually write all of the subsets of A. So in other words, how many subsets can we make of A? Well, the empty set is always a subset of A. Okay, of any set, the empty set is always a subset. Then you always have a set that contains each individual element. So I have individual element 1, element 2, element 3. Okay. Then I have a set that has two elements, 1 and 2, 1 and 3, and then I can have 2 and 3. So those are the only ways I can have two elements. All right. And then I have the set, actually the full set, 1, 2, and 3. So these are all of the ways that I can have any smaller sets of the big set. So if you count all of these up, I have 1, 2, 3, 4, 5, 6, 7, 8. So it turns out that I can have a total of 8 subsets. Now that's not so bad when I only had 3 elements. But let's say you had 50 elements. Who wants to go through there and list all of those elements? I sure don't, because that would take a really long time. So I'm going to give you a mathematical formula to help you out. It turns out that the total subsets is with this formula, 2 to the n power, where n is the number of elements in the set. So in this case, we had 3 elements in this set, so we had 2 to the 3rd power. And if you remember from last week, that meant you said 2 times 2 times 2. Or you got your calculator and you said 2 to the 3rd power or 2 to the 3rd exponent on your calculator, and you would get 8. All right. So if you had a set that had 5 elements in it, you would say 2 to the 5th power. If you had a set that had 50 elements in it, you would say 2 to the 50th power, and then you would get your answer, and that would be the number of subsets. All right, so hopefully that will help you. I think you're going to have at least 1 or 2 questions on your homework that are going to ask you about that. All right, if you have any questions or problems, check out your textbook. You can also email me or send me a text message. Thanks so much, and I will look forward to hearing from you.